are trying this again. Oops. All right, we're going to simplify each expression. So what we're going to do to simplify each expression, I'm just going to say it one more time because we weren't recording before. We're not solving. There's nothing to solve for. There's no equal sign. There's no number on the other sign or any expression on the other side of an equal sign. There's nothing to solve for. All we can do is simplify, meaning let's look for like terms and combine them. So I see a negative 5y. And I see a 10y. I see that they're like terms, so I'm now going to add them. So I have a negative 5y plus 10y is going to give us a positive 5y plus 2x. I cannot combine a 5y and a 2x because they're not like terms, they're different variables. So we end it here. This is our simplified expression. So now in number 2, I do see like terms. I see A's that are like terms and I see B's that are like terms. But there's a problem. I can't combine those like terms because something's blocking it. Anybody see what's blocking me from combining like terms? Noah? Excellent. When I used to teach this, I always used to say that parentheses are roadblocks. Nothing can be done, nothing can move, nothing can be combined until we get rid of those parentheses, unless you're within the parentheses. So before I can look for like terms, I need to get rid of the parentheses. When you have an expression and then parentheses, we need to distribute. So I'm going to first distribute that positive 2, and when you distribute, the operation we're doing is multiplication. So 2 times A is A, 2A. 2 times 6B is 12B. Am I done distributing? No. What do I need to distribute now? Good. I love that Leilani didn't say just 3. She said a negative 3. You always have to take the sign of the number that you're distributing. So since that was a minus 3, you consider it a negative 3. So now we are going to distribute that negative 3. So when I distribute in, we're multiplying. So negative 3 times 2a is a negative 6a. And a negative 3 times a negative b is a positive 3b. Now that I got rid of my parentheses, now I'm going to combine like terms. Anything that has a minus, we treat it like a negative number. So in my mind, everything's a plus, but if it's a minus, then it's plus a negative. So for example, when I have a 2a and then you have that minus 6a, I treat that as 2a plus a negative 6a. So 2a minus 6a or 2a plus a negative 6a is going to give us a negative 4a. Perfect. And then we're going to have 12b plus a positive 3b gives us 15b. And then I have an a and a b, not like terms, so we end there. Okay, I want you guys right now to try 3 and 4 on your own, and then we'll go over it. Okay, let's go over this. For number 3, I see like terms. I see a positive 6x and a positive 4x, which gives us a positive 10x. And then I have a negative 3y and a negative 2y. So if I have negative 3y plus a negative 2y, that's going to give me a negative 5y. And then the 1 stands alone. There's no combining it with anything, so we just write plus 1. How many people got that completely right? Perfect. All right, for number 4, before we can combine any like terms, I need to distribute. I'm going to distribute the positive 3, and I'm going to distribute the negative 4. So 3 times x will give us a 3x. 3 times a positive y is a positive 3y. Then we have negative 4 times 2x is a negative 8x. Negative 4 times a negative y is a positive 4y. And now that we got rid of our parentheses, now we can combine our like terms. So I have a positive 3x and a negative 8x gives me a negative 5x. And then I have a positive 3y and a positive 4y gives me a positive 7y. Now remember, addition's commutative. So if you ended up putting 7y minus 5x, that's the same. How many people got that right? Okay. I'm going to jump around a little bit. We'll go to number 5 and then jump around. So here I have the parentheses, which means we have to distribute. So I'm going to distribute the positive 5, but that positive 5 is going to all 3 terms, and the positive 6 is going to all 3 terms. So 5 times a is a 5a, 5 times a negative b is a negative 5b, 5 times a positive 2 is a positive 10. Now we're going to distribute that positive 6, so we are 6 times 2a is a positive 12a, 6 times b is a positive 6b, and positive 6 times a negative 5 is a negative 30. If I'm going too fast, just tell me to slow down. So after we distribute and we get rid of the parentheses, now we're going to look for the like terms. So I have a 5a and a 12a, both positive, so that gives me a 17a. And then I have a negative 5b and a positive 6b. So negative 5b plus a positive 6b is a positive 1b. Do I need to put the 1 in front of the b? No. Could you if you wanted to? Sure. All right, and now we're going to say positive 10 and a negative 30. That's also like terms. So positive 10 plus a negative 30 is a negative 20. All right, looking at number 6, do we all agree that they're all like terms? So just as a refresher, even though they have exponents, you're only adding the numbers in front. So when I have 4x squared plus a 3x squared, that's going to give me 7x squared. And then when you have 7x squared plus 3x squared, that's going to give us 10x squared. So when they're like terms, even when they have exponents, you only add the coefficients. You only add the numbers in front. You keep the variable and the exponent the same. Look at number 7 here. Actually, we'll do 7 and 8. Okay, so for 7, I see no parentheses, so I could go ahead and combine my like terms. And do we all agree that 2ab squared and minus ab squared are like terms? And do we also agree there's really a 1 in front of here, even though it's not written? So now when I have 2ab squared plus a negative or minus 1ab squared, so I have 2 minus 1 or 2 plus a negative 1, that is just a positive 1ab squared. Do I need that 1 in front? No. And then I have a negative 7 c squared and a positive 8c squared. So I'm thinking negative 7 plus 8 is a positive 1c squared. For number 8, I see parentheses, so I'm not going to combine any like terms until I get rid of the parentheses. So we're going to distribute in that positive 2. So we have x minus 3y plus 2x. 2 times x is a 2x. 2 times 2y is a 4y. And then we have a minus 3x. And now I see multiple like terms. I see a positive 1x, I see a positive 2x, and I see a negative 3x. So I'm going to add all of those together. So do we agree 1 plus 2, 1x plus 2x is a 3x? But then if I just take a 3x away from that, what happens? 3x minus 3x or 3x plus a negative 3x, what happens? They cancel each other out. So basically all my x's just canceled out. So we're not writing any x. I'm not going to write 0x because 0 means there's nothing there. So now what's left? We're left with a negative 3y, and don't forget that sign there, that is a negative, and a positive 4y, which is going to leave us just with 1y. So our answer is just y simplified. I think we can skip all these. Okay, when it says evaluate each expression, it means to substitute in the value for the given variable and simplify. I left out a word here, didn't I? The given variable and simplify. Okay, so when it says if x equals 2 and a equals 4 and t equals 6, this means to sub in to when you see an x for when you see a y, and 6 when you see a t. So here it says evaluate each expression if x equals 2, a equals 4, and t equals 6. So what I like to do is before I actually substitute in, I like to see, can I simplify this? Can I combine any terms? So for number 12, can I combine any like terms? No. So it's just a straight sub in first. So here I have 5, nothing to do with that. I have an a and an x. So I have a value to substitute in for a. I have a value to substitute in for x. When you have two variables that are right next to each other without any operation sign between them, what operation is implied? Excellent. This is multiplication. So this is saying 5 plus 4 times a. Well, we said a is 4, so I'm going to show parentheses to show my multiplication. And then it says x is 2, so then we're going to say times 2. So now we have to decide, do I add first or do I multiply first? And what tells me whether to add or multiply first? How do I know what to do first?
Order of operations.
Excellent. Order of operations. Do you guys all remember PEMDAS, or did they call it GEMDAS now? No, still PEMDAS? All right. Some students say their teacher said GEMDAS. All right. So we are going to follow PEMDAS. So PEMDAS tells us the order of operations. So P is for parentheses, E is exponents, M multiplication, D division, A addition, S subtraction. Now remember, with the M and D and A and S, it's not always multiplication before division. It's whatever comes first. So it's multiplication or division, addition or subtraction. So here we have addition and we have multiplication. So according to PEMDAS, multiplication is definitely first. So we're going to do 4 times 4 is 16. And then we're going to do 16. So we have 5 plus 16 times 2. We still multiply first. So 16 times 2 is a 32. So now we're left with 5 plus 32, which is 37. So now we have evaluated the expression. Again, for number 13, there is no like terms to combine first. So now I'm just going to do straight sub in. X is 2, A is 4, and T is 6. Do we all know the fraction bar means division? Okay, and now according to PEMDAS, we have to do division before addition. But when there's a long division bar, sort of like what we have here where it's underneath the whole expression, it's sort of a grouping too, meaning the numerators group together. So even though the parentheses are not there, when you have a long division sign, when you have that long fraction bar, it's saying whatever's above that is grouped together in parentheses, so we have to do that first. So I'm going to go ahead and I'm going to say 2 plus 4 is 6, and then 6 divided by 6 is 1. All right, let's do number 15. Skipping number 14. So number 15, I have 6. And then I have x. Well, x is 2. And then the power of 5. Do you guys see how that power of 5 is only on the x? It's not on the 6. So 6 is not being raised to the 5th power. If I wanted the x and the 6 raised to the 5th power, what that would look like, it would have to be this. In parentheses, 6x raised to the 5th power, then the quantity of 6x would be raised to the 5th power. But here, that exponent is only on the x, so only the x is raised to the 5th power. Do you all see the difference? Okay, because that's a big mistake. That's a very common mistake. All right, so now, according to PEMDAS, I have to do exponents before I multiply. So we're going to go ahead and we're going to do 2 to the 5th power. 2 to the 5th power is not 10. 2 to the 5th power is 2 times 2 times 2 times 2 times 2. So here, I'm going to jump multiply. 2 times 2 is 4. 2 times 2 is 4 again, and then 2. So then we're going to have 4 times 4 is 16. 16 times 2 is 32. So now I'm going to have 6 times 32. And we're at 192. I want you guys to try number 17 on your own. And then once you're done, I want you to zoom in on your Chromebooks and hold it up for me to check. Number 17. You guys are trying 17 right now on your own, and then as soon as you're done, you're going to hold it up so I can check for you. If you need help, raise your hand and I'll come over and help you. Perfect. It's okay, even if it's not. It's perfect. Good. You're perfect. You're good. Could you zoom in a little bit for me, Jonah? I just can't see from back here. We're just missing your work is perfect up until the end. You're missing your sign. What sign should that be? Now you're perfect. Anybody need my help?
What do you sub in to A?
So let's see. Up here. So it says A is 4. There's 4 x's, 2, t is 6. Welcome. How are you doing? Oh, you're doing great. Almost perfect. 4 times 6 is 24, 28. And then you would have been perfect. Almost perfect. We're taking a big 24 away from a little 4. So 4 minus 24 should be, you got it. Perfect. Um, 2 squared is 2 times 2, which is 4. You got it. Almost done. And then when you're taking a big 24 away from a little 4, should it be positive or negative? Negative. You got it. All right, moving on, let's step it up a little bit. Here. Okay, so right now it says evaluate each expression, but what I'm noticing is that they're like terms. So instead of plugging in right away, I'm going to say let's combine these like terms and then plug in. So we're not dealing with so many numbers. So I'm going to see a negative 4x and a positive 2x. And when we have a negative 4x plus a positive 2x, we're going to get a negative 2x. And then we're going to have a negative 3a and a positive 3a. What happens, though, when you add a negative 3a and a positive 3a, Caitlin? They cancel right out. And then there's nothing that matches with the 2t, but we still got to just bring it right down. So plus 2t. So now that I've simplified, I've combined as many terms as I can. What I want to do now is plug in for the values. So at the very top, it says x is 2 and t is 6. So we're going to have a negative 2 times 2 plus 2 times 6. And according to PEMDAS, we have to multiply before we add. So negative 2 times 2 is a negative 4. And then 2 times 6 is a positive 12. Now we got to remember our sign rules. When we're adding a negative 4 and a positive 12, that's going to give us a positive 8 because 12 is bigger than 4. All right, I want you guys to try number 19, and then we will be done for the day learning. So I would recommend simplify first. Before you sub in your numbers, just raise your hand so I can check your simplification before you go to the next phase and then mess it up. Oh, sorry, 3 eggs. Oh, no, that is an egg. Yep, you're perfect. So I want you, this isn't wrong, but before you substitute in, let's erase this, I want you to combine your like terms first. So when you have 1x squared plus 1x squared plus 1x squared. What's that? 1x squared plus 1x squared, 3x squared. And then negative a plus a negative a plus a negative a. You got it. Now sub in those.
Wait, I don't think I did this right.
No, because remember, with the like terms, you only add the numbers in front and you leave the exponent the same. So 1x squared plus 1x squared plus 1x squared is a 3x squared. Perfect.
They told me this one.
And then t is 6. Oh wait, no, that's an x. Sorry, that was a t. Yep, you're good. You got it. Perfect. Yep, you're perfect. Perfect. Ooh, according to PEMDAS, do we do exponents first or multiplication first? There we go. Yep, so inside the parentheses, not outside. All right, while you're working on that, I'm actually going to stop recording now, and I'll post your homework.